Good morning again to some of you, and first time for others. I'm Marilyn Barger. I'm the Senior Educational Advisor for FLATE. And this morning we have a brand new PhD from University of South Florida Mechanical Engineering Department who's going to talk to us about using Python for machine learning and manufacturing. And Purvi is going to jump right in. She has a lot to say and to share with you today. And it's also the beginning of a kind of two-part series. The webinar in 2 weeks will follow up, kind of pick up where this leaves off at the end of today. So Purvi, are you ready?
Yes, all set. So, good morning, everyone. My name is Purvi Bhatia, and today we are going to be talking about the buzzword that is today, which is machine learning and AI in manufacturing. So, I'll walk you through a couple of different things that we'll do today. So, for today, we are first going to be talking about AI, the evolution of AI in manufacturing. Then we'll talk about the next big thing in artificial intelligence. We are going to be touching upon it briefly, which is AI agents, which are coming up to be the next big frontier in all of AI, even in manufacturing. After that, we'll briefly go over Python for those of us who are maybe new to Python or are not familiar with the language. We'll go over some of the basics just so our follow up coding that we do and the code explanation that we do gets easier. Then we'll talk about machine learning and neural networks. We'll also learn about convolutional neural networks, which is a different type of neural network that we use. We are also going to be getting into computer vision. So we'll be translating back and forth between this presentation as well as the Jupyter notebook, which has all of the codes written, which I'm going to be sharing with you today. So let's get started. Perfect. So today, manufacturing and other industries, they are no longer strangers to innovation. Over the past decade, the fourth industrial revolution has played out and it has brought forward various new technologies, including Internet of Things, advanced analytics, AI, and so forth. Today's manufacturing scenario has something known as a smart, hyper-connected, and data-centric approach, and which leads to more efficiency, more data-driven insights, and all of these things. Now, over the next few years, we are going to be seeing how manufacturing is going to embrace AI, robotics, and IoT. In today's world, based on the boom of AI, we see a lot of different words that are being used interconnectedly, and they've become increasingly common. We have artificial intelligence, machine learning, deep learning, and generative AI. Now, all of these buzzwords are generally used interchangeably, which kind of creates a confusion about their true meaning. So, I wanted to quickly touch upon what all of these words mean. How are they interconnected? What kind of similarities do they share? And what are their own unique characteristics before we dive deep into learning about all of these things in manufacturing? So now AI is essentially a broad field, and it is broadly defined as the ability of the machines to mimic human behavior. So essentially, AI is used for enabling machines to perceive, learn, and reason, and therefore make decisions. Some common applications of artificial intelligence today basically include our virtual assistants that we have. For example, we have Siri, Alexa, and other voice-based interaction systems. We also have healthcare diagnosis, we have virtual reality, augmented reality, so on and so forth. Now, under this broad umbrella of artificial intelligence comes a subset which is known as machine learning. Now, machine learning is basically focusing on learning the data, learning from data without the explicit need for programming. So, when we mention machine learning, we actually leverage statistical techniques to automate patterns, and make predictions based on the historical data that the machine has been trained on. Now, machine learning emerged to address some of the key challenges in AI systems, which is the power of data. Data is king today. And machine learning has been used in various tasks, such as your recommendation system. So, the insights that you get on Netflix, what to watch next, what not to watch next, all of that comes under machine learning. Your credit scoring, your text classification, all of that is machine learning. Now, moving forward, there's another small subset which is called deep learning. Now, deep learning is a separate branch of artificial intelligence which has its own unique capabilities and advancements. Now, deep learning utilizes neural networks, which we'll be talking about moving forward in this presentation. And deep learning essentially automatically extracts relevant features from the data. So it is slightly more advanced than your machine learning approaches in a way that it basically learns from the data directly as humans would do. And it is used in a lot of techniques like autonomous vehicles, it is used in facial recognition systems, and so on. Now that we have all of that, we have another word that has been come up, which is called Gen AI or generative AI. Now, generative AI is a branch and subset of deep learning that focuses on creating models that are capable of generating new data which resemble existing data. Hence the word generative AI. Now, generative AI are very popular because these models aim to create data which is kind of indistinguishable from what is actually created by humans. So, you have your image generation, you have your various models such as DALI, which generate images, or we have video generation platforms, we have social media content generation platforms. So, all of that comes under generative AI. So all of these terms are something which we'll be using a lot in today's webinar and also the webinar that we move forward with. So hence I wanted to give a broad idea as to what are all of these individual terms mean. So just a quick question. Now that we know the different aspects of artificial intelligence, we know what's machine learning, deep learning, the most commonly used model today, which is ChatGPT. What do you think ChatGPT is? Is it an artificial intelligence model? Is it a machine learning model? Is it Gen AI? What do you think it is? If anyone could maybe unmute and reply or message. Oh, someone said both. Well, yes, kinda. It's actually all three. It's artificial intelligence, machine learning, and if we are using it to generate new images, or when we ask ChatGPT that, you know what, maybe I need an image of an apple, then it becomes Gen AI. So it's actually a amalgamation of all three. It has been trained on historical data. That is how it basically provides us with all of the solution. At the same time, it is also learning like a human would do from the data that we provided, and it also generates different type of data. So our most commonly used tool today is an amalgamation of all three. So moving forward, let's talk about the opportunities of machine learning to enhance manufacturing. Now, as I mentioned, AI has been deeply, it's creeping in into manufacturing, has been for quite some time. And there are quite a few cases that machine learning is used in manufacturing. Since we have a lot of data in a lot of our environments, we use it for predictive maintenance, we use it for inspection and monitoring techniques. We are also building digital twin. We are using it to identify our resource allocation, our energy consumption. So all of these things encompass the use cases that we have for machine learning and manufacturing. Um, Commonly, the most four common areas that we see it being utilized in is your operations. So essentially real-time adjustments to prevent any downtime as a maintenance companion. So for predictive maintenance and to assist personnel with maintenance tasks. With quality inspection, it has been heavily used and is being used as an automated quality inspection method and to eliminate any repetitive or mundane tasks that personnel might have. So these are basically a few use cases of machine learning in manufacturing, and we'll be touching upon quite a few today. We'll be talking about our quality. We'll also have a maintenance related example, which I'm going to be showing. So quickly wanted to give you an idea as to what to expect from our codes today. Now, let's briefly talk about another thing, which is AI agents for manufacturing. A lot of you might have heard this word come up recently, which is called AI agents. And I wanted to also briefly touch upon this new thing because slowly and steadily it's gaining momentum. So, what are AI agents? So, AI agents is essentially a software program with its own, which can interact with its own environment. So it will collect data, use that data to perform self-determined tasks and predetermined goals. So essentially, humans would set the goals, but the AI agent would independently choose how it needs to perform all of the actions to achieve these goals. So they are all autonomous. Now, for example, if an AI agent, we ask an AI agent to solve a customer inquiry, it will automatically ask the customer different types of question on its own, look up the information, and determine how to respond with the best solution. So humans provide the task, but it does the execution and determines what kind of execution it would want to do. Now, AI agents are being used in general for improved productivity, since they can perform tasks without any human intervention. They're also being used to reduce costs because if an AI agent can confidently perform complex tasks, we don't need human intervention there in some of the tasks that can be automated. Then we have informed decision making. Since it's collecting massive amounts of data and learning based on those data, it can help us analyze different demands, it can help us forecast a lot of things. And specifically in manufacturing, AI agents have found a lot of use cases. Uh, in manufacturing, basically, we have two different types of agents. So one is near autonomous and one is completely autonomous, by which I mean that somewhere we require a human intervention and somewhere it can be completely autonomous. Now, different use cases for AI agents in manufacturing range from all the way from quality control to supply chain optimization. We have quality control where we basically can inspect large amount of reports or documentation and data to identify any patterns and defects and essentially do a root cause analysis. Then we have predictive maintenance where it can be used to reduce any downtime, lower any maintenance costs. We also have inventory management where forecasting can be done to plan and schedule all of your tasks. So on and so forth. We have our process automation where interactive training materials can be made and inconsistencies can be identified. Um, I also want to give you an example of a dashboard that's already existing in AI agents. So there's already a few organizations that work with AI agents and have started building dashboards. This is an example of a dashboard that is being used where it's a very simple dashboard if you see. So basically it has three areas where you have a risk management agent, a quality control agent, and a supplier evaluation management agent. So these are three independent agents that control three independent tasks. For example, the input that comes is maybe in the form of your inputs from sensors or different machines or operators about sensor readings or operational logs, so on and so forth. And the brain essentially is used for the cognitive function that a human brain would. So it would identify the agent's role and it will use the historical data and the past interactions it has had. And based on that specific knowledge, it will determine the appropriate responses. This is a dashboard that is already being used by one of the organizations. Okay, so now that we have an idea as to the new techniques that are being used in manufacturing today, I wanted to start diving into what today's webinar is all about. Before I dive into the Jupyter notebooks, I wanted to give an introduction, a brief introduction on Python, since that is the language that we are using in all of our coding. So I just wanted to give a brief idea to whosoever who maybe who someone wants a refresher, or just to apprise everyone of the common terminologies that you will be seeing in all of the codes today. So if I just shift my screen to my Jupyter notebook. Perfect. So this is Jupyter Notebook. This is what we are going to be using today to basically run all of our codes. This is an integrated environment where you can type in your information and also run the code seamlessly with all of the packages installed in it. And this is what we'll be using to demonstrate all of our coding examples. Now, we are working with Python today and have been for quite some time, because Python is basically a very high level language that can be easily interpreted. It is very simple and easy to read. It's also very versatile. Hence, we use Python for our different applications in machine learning and deep learning. So anything in Python is very simple. So I've written down simple codes. For example, once you have this notebook with you, which would be provided to you at the end of the webinar, you can use your own codes in here. You can integrate your own data with this Jupyter notebooks. So we generally start by just a simple statement known as printing something like print hello world. We do this just to see whether our Python notebook is working well. It's a very simple start line that all of us use no matter what language we are using, whether it's C, C++, or Python. So it's, as you can see, it's a very simple language. It's mostly like English. So I'll quickly dive into a few different uh, things in Python that we'll be talking about. So one thing which you'll see all throughout are variables. So we'll be using different types of variables in our files. So it's the type of data that you're working on. So you have your integer, you have your whole number, integer, which is a whole number, your floating numbers, your strings, which is names or sequence of characters, or your true or false values. So this code essentially tells you how to run your different types of variables. Um, as you can see, once you click on this tile right here and you click on the run button over here, the code is run and it will show you the output. So we can print the age of a person. So we can use a whole number like you've mentioned over here. We can use decimals or we can use names. Now, this will make much more sense as we go forward into our basic data structures. Now, in Python, we have several built-in data structures that essentially we use to organize and store data efficiently. Some of them are your list right here, tuple, set, and dictionary. Now, what is the difference between all of them? So essentially, your list is an ordered collection of items that can be changed after creation. So for example, if I type in a list which is apple, banana, and cherry, anything which I keep in it can be basically changed. So if I want to change out apple with cherry, oh sorry, strawberry, or if I want to change out banana with pineapple, I can do it later. So it can definitely be changed. Then you have your tuple, which is essentially an ordered collection which cannot be changed once it's created. So, for example, if I have 1920 and 1080 over here, I cannot change it once I make it. So, immutable collection. Then we have something known as a set. Now, set is an ordered collection that does not allow duplicate elements. So, it's all a set of unique numbers or any unique elements that you have. So, 1, 2, 3, 4, 5 can be unique. And so anything that does not have any duplicate elements comes under a set. Duplicates are automatically removed in a set. That's why it's not counted. Then we have dictionary. Now, dictionary is something that stores the data in key value pairs. For example, if I store the name and age, it will store it as a pair. So it essentially helps if we are using, for example, the name of a person with the age of a person, or the name of a person with maybe what grade they're in. So it's good for storing any key value pairs. So that is dictionary. Then we have our if and while, and for statements. Now, these are the statements that essentially help us in determining in which order will the code be executed. And hence they are known as control flow statement because they control in what order the code is executed. Now you have conditional statements like if, else if, which is ELIF, and else. And we also have loops, which is for loop and while loop. Um, in our conditional statements, we have if, else if, and else. For example, just to show you an example of how that would work in a code. So if we have a number, we assign a number as 10 or maybe 5. And now, if we want to ask the code that, you know what, print a positive number if a number is greater than 0. So if the number has been assigned as 10, we know that the number is 0, so it will become a positive number right here. Now, if I change it to maybe, let's say, 0. So now my number is 0, and my statement is if the number is greater than 0, it's a positive number. Else, or else if the number is equal to 0, then please print 0, or else prints a negative number. So now I've assigned it at 0, so that means this statement will come into picture, and once I run it, it's going to say 0 right here. Now, if I assign it any other number, for example, I say it's -1, and if I run the code, then it will say negative number because I have given it a flow to the code. I told the code that if it's greater than 0, then it's a positive. If it's equal to 0, it's 0. Otherwise, it's a negative number. So it controls and executes how each line will go one after the other. So these statements will basically check what that number is assigned to. Okay, is it this? No. Move on to the next one. Is it this? No. Then move on to the next one. So this is how control flow statements work. Then we come to loops. Now, loops are also very important, and this is something which you'll see very frequently once we move on to machine learning and deep learning frameworks, which is our for loop, while loop. Now, the purpose of the loop is essentially to iterate over a list. So, for example, keep repeating it until the condition uh, is no longer met. So that is the idea. The purpose is for it is to transverse through each element in a sequence or a list. And the loop will pick basically one element in it at a time. It will perform that task. Is it this element? No. Maybe the next one. This one? No. Then the next one. So, for example, if I give you an example of how that code would work in here for a for loop, where it is iterating over each element. So let's go back to our fruits list. So remember we had assigned a list over here, fruits. So it is already stored in here. So we are using this term called fruits. So once we assign a variable over here, it can be used again. So we see for fruit and fruit, print all of the print fruit. So that means that it will go over each of the item in that list and it will print all of them one by one. So for first fruit, it will print apple, banana, and cherry. Again, because our list can be changed, anything in our list can be changed. So if I have pineapple in here instead of apple, because our list can be changed, it will automatically get changed in here as well, if you see pineapple. So again, that reiterates the fact that our list can be changed, and also the for loop, which goes over each of the elements in our list. A while loop is something that keeps executing as long as the condition is true. For example, if I say that uh, till the time my count is 5, keep running it by increasing it +1 at a time. So this is what this code is doing. So basically execute it till the time we hit 5. And this is what it does. So the loop starts counting from 0 at proper increments of 1, and it will do that until it reaches that final value that we tell it to. And it will print each value at each step. So this is what for and while loop essentially do. Then we quickly have our functions. Functions is something which you will also see in our machine learning and deep learning codes. But before I get into functions, I would want to ask, does anyone have any questions so far? Okay. So I'll move forward. So
There was one question from
okay.
Ron that asked it, could we use Colab as our Jupyter host?
Sorry, I cannot hear it. May it's in.
Oh,
Oh,
can
can
you?
you just? Oh yeah. So definitely Colab can be used.
Great.
Yeah. Google Colab or uh, you can use directly Jupyter Notebook, or yeah, you can go through Google Colab. That's completely fine.
Okay, great.
Uh,
That's it. That's all I see.
okay. So quickly we'll go over functions. Again, this is just a refresher as to for Python, since we'll be using all of this very repetitively. Then we have our functions. Now, function essentially allow you to encapsulate your code into one reusable block to perform a specific task. That is the use of the function. So basically, what we do is we can assign it input parameters and it will give us output parameters. Now, just to give you an example of how a function would work, this is a very simple function that we have created. In this function, basically, we create a function with a greeting logic, and it can be used with different names. So our logic is basically to greet whosoever's name we type in here. So in case we create a function that greet so and so person, and the statement that we want to output is hello and the name of the person that we want. So this way, imagine that you have hundreds and hundreds of lines of code. This comes in handy when you have hundreds and hundreds of lines of code and you can't change every single parameter for every single line, because obviously that is very redundant, it is time consuming, it does not make sense as well. So functions is used there where you only have to change one thing in here, because when you call a function, you're calling the function greet, but you're asking it to greet that specific person. So I just have to change the name of the person. I don't have to go back to that function every single time. I'll use my argument in here. So for example, I write David and then I run the code. So now instead of Alice, it becomes David, right? So you don't have to go back to that same snippet of code again and again. You can just change it when you call the function. Uh, then we have another example over here, which is square of a number. So we are basically asking the function to calculate the square of any number. Now in here, again, we don't have to write the numbers again and again. If we didn't have a function in here, what we would do is we would basically go in and like do the square of the function again and again and again and write those numbers here. No. Instead, we just choose something over here. Right now, the square of 6 is 36. If we write 7 and then we write print square of 7, we run the code again, it will automatically do that. So functions essentially help encapsulate all of the things that we want to do repetitively. And the lambda function that I've used over here, if you noticed, I haven't defined a function in here. I've just used lambda. Now, lambda is a very concise and an anonymous way to create a function. So I've shown how to create a function in two types. Define is a regular way to create a function like normally you would. But lambda is an anonymous and concise way to create a function. So if you want something as simple as a square, you don't have to write define and assign a function and so on and so forth. You could just use lambda. uh, then we have our modules and packages. Now the good thing about Python is it comes built in with a lot of packages, and this is the final thing which we'll be going over before I jump to the machine learning module, and then we can quickly come back if needed. But Python is very rich in the kind of modules and packages that we have. What do I mean by module and packages? So these are all ready-made tools which are already inbuilt in Python. It's a collection of various functions, classes, variables, which can be used through third-party packages, and it can help us perform all of our tasks that we have on Python. For example, if you're doing square root of a number, we would need some sort of a module that does the mathematical operations. So that module is already in Python, which is import math. This math module will automatically import all of the necessary operations that we need to perform any mathematical calculation. For example, square root right here. Now, you don't need to remember all of the packages and modules that are available on Python. You have open source Python documentation that is available on Google that you can go through and identify which package is required for which tasks. So this is example of a module. The final thing which I'll be talking about is file input and output. Since this Jupyter notebook and the machine learning notebook that we'll be sharing today is interactive, you can use it with your own data. I just want to include an example of how to input your own file, uh, reading and like into your code. So in case we give you the Jupyter notebook and you want to work with it with your own data, you can do it. So you can read or write in file inside Python, and you can also interact with the files on your system. So this is an example of that. So Python can start writing a file, which is here. So it will, for example, if I create a file called hello file, and yeah, hello, my file content is hello file, but I create a file in here. So I can start with creating an example text file, and then I can read from the text file as well. So Python allows you to interact with the files on your system and files within its environment as well. Now, I'll quickly jump to our machine learning module. This was just a refresher to Python, but I would like to dive into our machine learning module from here. Okay. Great. Okay. So today we are going to be talking about machine learning, deep learning, and computer vision. I'll quickly translate over to our presentation first, and then we'll come right to the core part of it. So first we'll talk about machine learning, then we'll talk about deep learning, and finally we'll talk about computer vision. So let's break it up and go one by one. So first we'll be talking about machine learning. Now, before I dive deep into machine learning, I'll quickly go over what it means, and we already went through it earlier. So essentially, it is a branch of artificial intelligence that focuses on building algorithms and models that deploy on data patterns and inferences. And machine learning typically is divided into three types, which is uh, supervised, unsupervised, and reinforcement. Now, supervised machine learning type is a type where the model is trained on a labeled data set, by which I mean that the target or the outcome is already known, right? It's trust driven. So you need to predict the next value. That is called supervised. So it is used a lot in forecasting. For example, if you are creating a model for tornado forecasting, or if you are trying to identify flow patterns. So you already know the outcome, but you're trying to forecast it. So it is very task driven, and that is supervised machine learning model. It is commonly used for risk assessment, image recognition, fraud detection, and all of these types of areas. Then we have unsupervised machine learning models. Now, unsupervised machine learning models essentially help in exploratory data analysis. So anytime you have any data that does not have any labels assigned to it, for example, you might have 3 or 4 different types of data, but it's not been assigned to respective clusters. That is where unsupervised learning comes into play, because it will identify the patterns, and it will predict based on that. Then we have our reinforcement learning models. Our reinforcement learning models are something which work on a reward punishment sort of a thing. So essentially, it learns from its mistake. Uh, so a reinforcement learning model, to get to a predetermined goal, an agent is awarded or penalized. And by agent, I mean an agent inside the model is rewarded or penalized based on the action. So if it's rewarded, it knows this is the right step, move on to the next one. If it's penalized, then it realizes that, you know what, this is not a good practice, this is not the best strategy, move on to the next one. This is being used a lot in spam detection and recommendation engines, and also for predictive maintenance in the industry. So if I quickly, okay. So Moving back to our Jupyter notebook, we have an example of our machine learning code right here. So in this machine learning code, we are going to be talking about a simple library, inbuilt library in Python that is used to create a normal regression model. Now, what we have over here is essentially right here. Okay. We have a predetermined library which is called scikit-learn, which is already inbuilt into Python, which helps us perform all of the machine learning tasks in Python. Uh, sklearn essentially allows us to import the models that we are going to be training on. It also allows us to import the data sets. As I mentioned, Python has inbuilt data sets and modules. And it also allows us to import any metrics that we use to understand how accurate our code is. So in this basic workflow, using the scikit library, we have our models that we're importing. So we're importing our data set. We are using an iris data set. Iris data set essentially has features of different iris flowers and their species. So it's a label data set because it has if different I would say species has been assigned a different label. So it's a label data set. We have our model, which is performing a test chain split. So every time you are training a machine learning model, there's different aspects to it. For example, if I have 100 different data inputs, out of this 100 different data inputs, I want to train my machine learning model to predict maybe 20 unseen ones. So what I'll do is I'll split my 100 different data inputs into different parts. That is called the test and train split. Now, either I have 100 different points and I split this into test or train. For example, I take 80 data points, I train my model on that. So now the model learns from those 80 data points, and the remaining 20 data points I keep unseen. And then it learns, basically, once it learns all of the features on those 80 data points, it will predict based on the new 20 data points because it has not seen that data. For it, it's completely new. So that is called the test and train split. Sometimes you can also use those complete 100 data points because if you have a completely new test set, you don't need to, you can include that and have a proper split. But otherwise, if you have a complete 100 data set, you can perform that test train split. There's also known as validation in here. I've performed a simple train test split, but you can also have train validation and test split. What is the difference between both of them? In training and test split, you only have two different areas. You have a training data, which the model sees, learns from, and then predicts on the testing data, or you have train validation and testing. That means it will train on that data before going to its final analysis of predicting on the testing data. It will go through an intermediate step where it will check whether it has learned appropriate stuff from the training data. So that validation step comes in between. This is specifically beneficial if you have a very large data set because you would not want to train your model and then directly go and perform on your testing set and essentially does not work well and then you're going back and forth. So that's an intermediate step in between where you can test on some of that data to see whether your model is performing well. Great. If it is, then deploy your model on the rest of the data. But over here, since we are doing a simple thing, we are going to be using a test train split. So in here, we load the data set right here. So we load all of the features. Our X features are your sepal width, length, petal width, and we have our labels for each of those length and width. We split the data 80% and 20%. Always your training data is more than your testing data. That's the rule of thumb. If you have validation in between, you could do a 70 and a 30 split uh, or a 60 and a 40 split. But if you only have training and testing, you could do 80-20. And then we also call the model from here. This model is already there in Python since we are calling that specific module, if you remember, scikit-learn. It has the logistic regression model in it. Our logistic regression model, it is basically, we have maximum of 200 iterations. That means that the model is instantiated on these iterations. So it will learn over all of these iterations, and which will allow it to converge to a good accuracy. Then we have the prediction. So once the model is done training on all of the data, it will evaluate and make predictions based on the test set that we have. And then we have the accuracy. So the accuracy score is printed out in here. Since it's a tried and tested model, the accuracy score, if you just click on this, we run this, the accuracy score is 1 right here, because that means it's completely accurate. So we learned about data loading, we learned about data splitting, and we learned about model training in here. I've also provided a specific manufacturing example in this, where to demonstrate how machine learning can be used in manufacturing, which is a predictive maintenance example. Those of you who have attended our previous workshops know that we were using sensors to record parameters such as temperature, humidity, our CO2, so on and so forth. And we had used that data to in our machine learning models to predict essentially all of our emissions in an environment. So this is an example of simulating synthetic data. And there, the data that we had used that the actual data that were collected from the sensors. But if you don't have enough data, or you don't have you have discrepancies in your data, you can also use synthetic data to complement your actual data and run the model on here and have your predictive forecasting model. So in here, this is an example to show how we can use different sensor data to essentially identify whether our equipment is performing well or not. In here, what we've done is, I'll quickly go over the code. We have NumPy. NumPy is used for numerical operations and for generating synthetic data. Again, it is inbuilt into Python. Then we have our random forest classifier. It is a very robust machine learning model that is used for classification tasks. We have the same thing that we have here, which is splitting the data into test and train, that we have to do every single time. And then we have our accuracy metrics, where we show our accuracy score. Now we can generate our synthetic data directly using the NumPy library right here. It is very simple. So what it does is, it ensures this random seed ensures that the data is reproducible. And then we have synthetic features that are being assigned. So n samples equal to 200 is basically it's a 200 into 2 array, which is simulating the sensor readings that would come out of a temperature and a vibration sensor. And these values are drawn from a normal distribution with a mean of 0 and a standard deviation of 1. And this is so directly using the NumPy module. Then we have our target variables. So the features that we want to detect are basically from a temperature and vibration. So what we do over here is, we simulate a binary target where 1 shows impending failure and 0 is normal operation. For simulation, we assume that higher temperature and vibration will lead to failure. We combine our sensor data. So in here, we combine our simulation data, and we also add noise, because we want to kind of mimic a real world scenario, and in that we will have noise. So we combine the sensor data in here, plus we add, this is random noise, and we assign it a binary classification by seeing that if the sum exceeds 0.5, then the target is set to 1, otherwise it's 0. So that means if it's 1, failure, 0, normal operation. We again split the data into two types, which is test and train. And then we train the classifier, and post that we evaluate the model. Now, once I run this model, the predictive accuracy is 0.91. I'm not running this again over here because it takes a little bit of time to run the entire model, which you can obviously do. You just have to click on this cell right here and hit run. So once you run it, the model will run. I can just show it over here. It will take some time, and then it will show it uh, on based on the processing power. So since I'd run this model before, the accuracy had come out to be 0.91, which shows that the model is accurate up till 91% from the synthetic data. So this is an example of the machine learning model. Any doubts so far with the machine learning model? Or any questions for me? Okay.
No,
Uh, Sorry.
I don't see anything. Good.
Okay, perfect. So we'll move on to the deep learning model. So machine learning is a demonstration as to that you're learning from the data that has been provided. So the data is given, the model learns from that data and predicts on the new data. So that is what this is about. You can use this code directly with your own data that you have. And if you have any questions after the workshop, you can also reach out to me again to see if you have existing data and you want to work with that data. Then moving forward, we have our next category, which is deep learning. As I mentioned, deep learning is different from machine learning. How? Deep learning essentially, if you remember, is used to perform tasks that are very similar to understanding your how the human brain would understand it. So deep learning models can analyze complex pictures, text, and data patterns to provide accurate insights. How it is different from machine learning is if you see this image right here, right at the bottom right, where you have machine learning and deep learning. In machine learning, a human will perform feature extraction and then it will provide the data to the machine learning model, right? So we need to pre process that data, we need to assign it proper labels, so on and so forth, manually. So that is machine learning because we are providing data to the machine to learn from. Then we have deep learning. The beauty about deep learning is since it works like a human brain would, it will automatically extract relevant features from the data. And that is the key difference that exists between machine learning and deep learning, that that part is handled by the model and the architecture in itself. So you can use deep learning tasks to automate anything that would typically require human intelligence because it can automatically extract and understand features like a human brain would. So that is the key difference between deep learning and machine learning. Quickly, I'll go over a few important layers of deep learning. Every time you hear deep learning, you would hear these three things again and again: your input layers, your hidden layers, and your output layers. Once you understand how layers work, it's very easy to understand any model, any neural network model that you're working, because most of the models in the industry are neural networks. So I'll quickly go over what these three things mean because this is something you see every single time you have any model. Your input layer essentially is the layer that inputs all of the data into the model. Very simple. It will have number of neurons is basically how the brain has neurons. That's the same thing. It will have the number of features. Uh, in for an image, for example, that's the number of pixels. Our hidden layer is basically the layer into which the data is fed into. Now these hidden layers process information at different levels, and at every level they perceive new information. So for example, if you give it an image of an unknown animal and you compare it to the animal you already know, right? So the first layer will maybe look at the shape of the eyes, the second layer will look at the shape of the ears, number of legs, and it will identify patterns. So for example, if the animal has hooves, maybe it's a cow or a deer. Or if it has eyes that are similar to a cat, maybe it's a cat. So it will go through different layers, and then finally it is fed into the final layer, which is the output layer, where it consists of answers. So it will give you a yes or no answer. That, do you think it's a cat? Put it in the cat category. Do you think it's a horse? Put it in the horse category. So this is what the layers broadly do. Uh, in neural networks, we have something known as convolutional neural networks, which are being used a lot these days. Now, convolutional neural networks are a specified class of neural networks that learn directly from the data, as I was talking about. As I mentioned, you see these layers. You have input layer, and then you have your output layer. But in convolutional neural networks, you have a few different layers in between, which is your convolutional layer, pooling layer, convolutional layer, pooling layer again. Now, these are very simple layers. Convolutional layer essentially is basically a layer where we convert our image. For example, if you're working with image, we convert our image into small different kernels, which allows us to look at every single part of that image. So for example, if I have an image, I can maybe convert it into a 32 by 32 kernel, right? So I can identify each kernel and work on it and then piece the entire picture together. So in here, for example, one convolutional layer might be good at finding curves, one might be good at finding straight lines, one might be good at identifying patterns. So these layers essentially do that. Then we also have a pooling layer. In pooling layer, it is used to identify the most significant features from each of the convolutional layers. So basically what it does is it will reduce the memory that we use while training. It will essentially pull it together and create a feature map. And then we have fully connected layer. Now, fully connected layer are the last layer in any convolutional neural network that you'll see. And they basically flatten all of the matrix, the grid that I had, 32 by 32, into one dimensional matrix, right? And it will give you final score. For example, there's a high chance that this is a horse, this is a high chance this is a cat, so on and so forth. So that is a convolutional neural network. Like I mentioned, you have three layers: convolutional layer, pooling layer, and fully connected layer. Every time you see any neural network architecture, it would 99% of the times look like this. So if you see here is in the image, it's taking one aspect of this image. For example, right here, as I mentioned, it converts it into different grids. It will take one, look at that one, uh, extract the features, pull it together, maybe extract another feature again, pull it together, flatten it, and then give us what it is. Like this, it will go over the entire image. It will look at each of the grid and each of the kernel in the entire image, as you can see in here. Um, Again, this is an explanation, a broader explanation as to what all of these do, what are the common activation functions, what are the pooling layers and flattening layers. Now I'll quickly want to share the deep learning example. And after that, I want to show you a very interesting open source thing for deep learning. But the deep learning example that we have over here works with an MNIST dataset. MNIST dataset is basically a collection of numbers, and it is automatically, again, within our Python environment. So in here, we install a package known as TensorFlow. Now, what TensorFlow does is TensorFlow will help us in getting modules that are required for building a neural networks. For example, flattening our layers and creating dense layers. It will help us get that. And every time you have to install a new package in Jupyter, you can use this statement right here. So pip install, and you can write the name of the package right here, and it will install that package for you. So we load the data set, it's handwritten digits, that's what the data set it is. We normalize it, and then after that we convert it. So basically we transform each integer label into a binary vector, which is what we do in one hot encoded vectors. Because the normalization helps us converge faster during training. The labels help us transform each integer label into a binary vector. Then we have a simple neural network. Again, the reason I taught about layers is because you'll see sequential layers, flatten these layers a lot. So these are all the name of the layers which have which build the neural network. So our flattened layer transforms each 28 by 28 image into a 784 dimensional vector, right? Our dense layer basically introduces non-linearity. It has an activation function called ReLU. Then we have our final layer, which essentially contains 10 neurons. You don't need to know how to write this code, but understanding this code is beneficial because then you can change this code to your own task very easily. Now, to handle large data set, we have an optimizer generally. These optimizers help in increasing the accuracy. And finally, we run the model. Once we run the model, we see our accuracy right here, which is 97%. Now, these models and data set are readily available. There's no need to write these data sets from scratch. I want to demonstrate an example of what we use in general for our tasks on any data set or any model that we need. So what I'll do is I'll just share my screen. Okay. So if you share my screen, we just go to Google and we type Hugging Face. Hugging Face is this website where you can go to build your own, to get models that are pre-built. That means you only have to make some slight changes into it. So you don't have to underwrite the entire model because as even I'm not a computer science engineer, I don't know how to write the entire model from scratch. But understanding and changing the model is something that we can do. So Hugging Face gives you access to numerous models and data sets, which you can readily download and you can use it on your own devices. So in here, you have models. You have different models by each task. So you have computer vision models. For example, you have image classification, you have video classification, you have image segmentation. We have natural language processing, for example, anything that requires something like ChatGPT. So text generation, feature extraction, text classification. We also have tabular classification, time series forecasting. So if you click on any of this thing, for example, if I click on, let's say, image classification, all of the models that are already built by people online, it will show in here. And suppose if I open this one, it will tell me the model overview. It will tell me what it was built upon. It will show me the model performance. It will also show me the architecture. It will show me the usage. How do I install all of the things that I need? It will tell me what data set it was trained on. So it's Coco data set. Then it will also give me the entire code, right? The good thing is you can also use this model and train this model on this website. So you can use the Amazon SageMaker, or you can auto train the model without using this code and just using the data using the Hugging Face interface right here. And then you have your data sets. So in case you want readily available data sets also, you have your different data sets. You have your image data sets. All of these are image data sets. And then you have your audio data sets, your video data sets, your time series data sets in different format as well. So Hugging Face is a very good interface. If you want to, you can create your own login and you can directly train models within Hugging Face environment itself. So yes, how model is reused with new data after the model has been trained. Okay, so what happens is, for example, if I talk about this model, let me just share my screen. Let's talk about the DeepSeek model, for example, or let me show you the there. Okay, so for example, if this is trained on the MNIST data set, and this is the model that we were using. It's a very simple model. It was trained on the MNIST data set. Uh, the model has been trained up till a certain aspect, right? So if you want to train the model on the new data, there are two types of ways to do that. Type one is you train the entire model on the new data, right? That is one approach. Another approach is, since the model, if you're a target model, that is the data that you're training on, target data, and the data that it has already been trained on, if there's major similarities in it, then what you can do is you can freeze some of the layers. For example, these initial layers, and this is something we are going to be talking about in our next webinar, which is the one that is coming up in April. That is what we are going to be using. That's going to be an interactive webinar where we'll divide everyone into groups, and there you will learn how to use the models with your own data set. That approach is known as transfer learning. In there, either you freeze some of the model, right, and then you use that model, or whatever the model has learned from your source data set, you apply it to your target data set, which is your own data set. That is called one approach. Or you retrain the entire model if you feel you have enough data available to you, right? So there are two approaches, and that is how the model can be reused with new data, right? There we learn how, which model to use at what time, because if your source data set, which is what the model was trained on, and your target data set, which is what you want to train the model on, is similar, there's one type of approach. If it's not similar, there's another type of approach, which is something we are going to be talking in depth in the next workshop. And we are also going to be dividing into groups and implementing that example to see how these different approaches work with new data and pre-trained and pre-learned aspects of the data.
Kirby, I'm gonna have to interrupt. It's 11 o'clock.
Yes.
So we're gonna have to, we have just, I think you have just a little bit more, a couple more slides. I can't remember.
I, yeah, we only have, I think, computer vision left, which I think we can tackle in the next one. The deep learning part, which we require for the next workshop, is over today.
Okay,
Yeah.
okay. I don't want to hold anyone up
Mhm.
any longer. So please, if you have questions, you can send them to me.
Mhm.
And let's see, we'll put her email in the chat. Can you do that?
Yes, definitely. And to the question about how the model is stored, you basically freeze certain parameters in a model. So you have checkpoints in a model. You freeze it up till a certain point. So that means that is stored, and then you retrain the further layers, which we'll talk about in the next one. That was a question by Daryl, I believe. Just to, uh, I hope that's clear. But yeah, that we'll talk about in the next webinar for sure, and that is something we are going to be doing in the next webinar.
See if I got I've just put your email
Yes.
in the chat.
Yes.
Sorry,
Nice.
sorry about that, everyone. I should have done that earlier. And okay, so any final questions, you can email Purvi directly. And where's the Jupyter notebook file you were going to, do you have that PDF?
Yes. So I'm going to be sending the PDF and the Jupyter notebook file. Uh, do we email it or?
Yes, I guess so.
Okay.
But at
Perfect.
this point in time, once we have the list of people who are
Right.
here, so we'll send a PDF of the slides and a PDF of the Jupyter notebook, so you can go and open your own or see the code that was within here, and get your own Jupyter file set up, or what was it that Ron wanted? Oh, collab,
Yes.
however you want to use this kind of code. So those will go out probably later today. Is that right? We have those
Yes.
ready? Okay.
They will go out today, and I'll also attach the actual Jupyter notebook. So if you already have that environment, you can just open that notebook. It will open on your
I guess
system.
Okay, well, we hope to see some of you again in 2 weeks on April 11th, and we'll continue this journey into understanding some of the background behind really applying how does the machine learning learn, and how are some simple ways we could help our students with some simple input data or synthetic data that we gathered to have them experience what the outcomes might be in machine learning. And as always, I think we're trying to help our students be able to understand what's happening in a system and be able to backtrack, troubleshoot what has happened. So understanding a little bit about what's going on in the AI environment, the whole AI environments, will certainly help them to better troubleshoot some of their issues on the floor. So have a great weekend, everyone. Thanks so much, and you'll be getting an email this afternoon. Thank you.